Hello, this is a continuation of the other part 6 video. Specifically in this part, we're going to be focusing on average atomic mass. So in that previous video, we talked about the periodic table and how the periodic table tells us three important pieces of information. The first is the atomic number that tells us the number of protons an element has. So hydrogen has 1 proton, helium has 2 protons, and so on. The second is this letter. This is the atomic symbol. So H stands for hydrogen, He stands for helium. So that tells us the name of the element. And the last, and this is what we're going to be focusing on during this video, is this number down here. This is the average atomic mass. So what this number means is if we have all of the hydrogen atoms in the entire universe and we calculate the average mass of those hydrogen atoms, the average is 1.008. And this is an AMU. And so this tells us that most hydrogen atoms have a mass of 1. Most hydrogen atoms have 1 proton and no neutrons, but there are a few isotopes of hydrogen. One isotope has 1 proton and 1 neutron, therefore having a mass of 2. So there are some hydrogen atoms that actually have a mass of 2 AMU, but most hydrogen atoms have a mass of 1 AMU. And there's even a few that have a mass of 3 AMU, that have 1 proton and 2 neutrons. But if we add all of those hydrogen atoms up together, find the average mass, so divide by the total number of hydrogen atoms, we would get 1.008, which tells us that almost all, like 99% of hydrogen, has a mass of 1. It's just made up of 1 proton and no neutrons. So we are going to learn during this video how to calculate the average atomic mass of elements and how to use the average atomic mass. So again, I just want to make this distinction of the mass number and the atomic number, the mass number and the average atomic mass. So the mass number is also called the atomic mass, and it's the mass of a single atom. So it can be calculated by adding the protons plus the neutrons. That tells us the mass number, and it's the mass of a single atom. Versus the average mass, the average atomic mass, is the average mass of all of the isotopes of an atom. So just a reminder, isotopes are atoms of the same element. So they have the same number of protons, they're the same element, but they have different masses. So they have different numbers of neutrons. And we can use this formula to calculate the average atomic mass. This allows us to calculate a weighted average. So we take the percentage of one isotope and multiply it by the mass of that isotope. And then we add it to the percentage of the second isotope times the mass of that isotope, and so on, depending on how many isotopes you have. Let me give you a little bit of an example for this. This is boron. I know this is boron because in my picture on the left, it has 1, 2, 3, 4, 5 protons, 5 of those positive pink circles. And on my picture on the right, it also has 1, 2, 3, 4, 5 protons. If we go back to the periodic table, notice that when we have 5 protons, we have the element B, which is boron. So here we have 2 isotopes of boron. I know these are isotopes because when I count the green circles, 1, 2, 3, 4, 5, 6. So this one has 6 neutrons and 5 protons. And the one on the right also has 5 protons, but if you count those neutrons, there are 5 neutrons as well. So these are exactly the same element because they both have 5 protons, so they're both boron atoms, but these atoms are isotopes of each other. They have different masses. So one of my boron atoms, the one on the left, has a mass of 11, right? 6 plus 5 is 11 AMU, and the one on the right has a mass of 10 AMU. So these are my 2 isotopes. So if 50% of my atoms of boron had a mass of 11 and 50% of my atoms of boron had a mass of 10, then I could tell you, oh, the average between 10 and 11 is 10.5. So my average atomic mass would be 10.5. When I look at the periodic table, I see that my average is actually 10.81, which means that I have quite a few more boron atoms that have a mass of 11. 10.81 is closer to 11 than it is to 10. And when I look at the percentages of my boron isotopes, I notice that 80% of all boron has a mass of 11 AMU, and 20% of all boron has a mass of 10 AMU. So in order to figure out my average atomic mass, I need to multiply the percentage times the mass of each isotope. And the percentage needs to be converted into a decimal. So 20%, just a reminder, percent means out of 100. So 20% is 20 out of 100, which would mean that I have really 0.2 and when I convert it into a decimal. So you can divide by 100 or you can move that decimal place over 2 spots. You will get the same number that's doing the same thing. So what I need to do is I'm going to do 10. That's my mass for isotope 1. I'm going to call this one isotope 1. And this will be my isotope 2. So 10 is my mass times 0.2 plus the mass of my second isotope and the percentage of my second isotope. So 80% again becomes 0.8. I divide by 100. Percent means out of 100. And I'm going to multiply that by 11. And so when you multiply these and add them up, you get about 10.81, which is our average atomic mass for boron. So I'm going to do one more example, and this example is in your summer packet. Silver has 2 isotopes, one with 60 neutrons and the other with 62 neutrons. Okay, so again, we're talking about isotopes, so same number of protons, same element. They're both silver, but different masses. Give the chemical notation for each of these isotopes and calculate the relative abundance for each isotope, given that the average atomic mass for silver is 107.87 AMU. And so that number can be found on the periodic table when we look at silver. Here is silver. It has 47 protons, and the average atomic mass is 107.87. Okay. So we know that we have 2 isotopes, and when we add them together, the average atomic mass is 107.87. So when I add my percentage times my mass of the first isotope plus the percentage times the mass of the second isotope, I will get my average atomic mass. I need to calculate the relative abundance. So I want to know, is it 50% each? Is it 25 of one, 75 of the other? What is the percentage? The percentage is the relative abundance. I know my masses because I know that I have 47 protons in silver. And so if I have 60 neutrons for one isotope, so 60 plus 47 would give me 107. And then I have 62 neutrons for the isotope, so 62 plus 47 would give me 109. So I have these 2 isotopes. Those are my 2 masses, 107 and 109. And I need to figure out what percentage each one is. Now I know that percentage always means out of 100, right? So when I add my percentages together, it has to equal 100. Or really, when I add my percentages together, because in this case, I'm putting them in decimals, it has to add up to 1. So when I add my percentages up, it has to equal 1. So I'm going to solve this equation for my second percentage. So I'll subtract percentage 1 from both sides. And now I can substitute this in for my percentage 2. So this is algebra substitution method. And so I get this equation, right? 107.87 equals percentage 1 times 107 plus, and then I just substituted that in, 1 minus percentage 1 times 109. And now I use the distributive property. So I'm going to multiply both of these by my 109 to separate that out. So 1 times 109 gives me 109, and then negative percentage 1 times 109 gives me minus percentage 1 times 109. And now I'm going to combine like terms. And so what I'm going to do is I'm going to subtract my 107.87 from both sides. So I'll find the difference between 107.87 and 109. And I'm going to add my percentage 1 times 109 and subtract my percentage 1 times 107. So looking at this, you can really see that I'm doing, the way it's written here is percentage 1 times 107 minus percentage 1 times 109. So 107 times minus 109 would be -2. So when I move my percentage to the left side and my numbers to the right side, I get 2 times percentage 1 equals 1.13. Now, if you didn't switch sides, you would just get negative 1.13 equals negative 2 times percentage 1, which is exactly the same thing. So as you're solving this, you can leave it like this as well. Notice you just be dividing by -2 instead of by 2. So in this case, I'm just going to divide both sides by 2. And so I get percentage 1 equals 0.565, which is 56.5%, right? When I move that decimal place over 2 spots or multiply by 100, I get my percentage. I know that my percentages have to add up to 1 in the decimal form, or the percentages themselves have to add up to 100. And so therefore I can do 1 minus my percentage 1, which equals 43.5% for percentage 2. So therefore, my answer would be 56.5% is silver 107 and 43.5% is silver 109. The second thing I need to do is give the chemical notation for each of these isotopes. And so when we're talking about the chemical notation for the isotope, we always start with our isotopic symbol or our atomic symbol, which is silver, Ag. The top number is going to be the mass. So this one will have a mass of 107. And the bottom number is our atomic number, or the number of protons. So these are our chemical notations or isotopic symbols for our 2 isotopes of silver.